Summer research fellowships. If you're interested, students that are interested, pass the word around. You should go to www.ohio.edu/fellowships. And you'll find a list of fellowships and things that you can apply to. You also find some contact information there for people who can help you with these applications or give you some more information. Also, important to know, the next Science Cafe, which will be the last one for the fall semester, will be December 11th, 3 weeks. December 11th, it's Dr. John Kopchak from the College of Medicine, the Biotech Institute. So, with no further ado, Dr. Deb McAvoy from Civil Engineering and All About Driving.
All right, how you guys doing tonight? Good? All right, so who in here is not a driver? All right. So I'm going to go out here. What is a red sign that's kind of like an octagon? What is that? Stop sign. Very good. How about that? We should give our driver's license right now. So we're going to talk about drivers, why they don't do so well. This is called, Designing Roadways for Dummies. Anybody in here think that they're an excellent driver? We're going home right now. This is not going to work. All right, what I'm going to do, I'm going to pull up a couple small videos, very small clips of the Athens Roundabout. Everybody in here has probably driven the Athens Roundabout and has their own personal opinion of it, right? Who thinks it's a great asset instead of the signal? All right, sir, why do you think it's a great asset?
I think
Yeah.
because it moves traffic faster. It's probably as safe as stoplights. So I think it's a win-win.
Okay, so it moves traffic faster and it's safer than stoplights, with the exception of yesterday's crash, right?
I said it's about as safe as
Okay. Does anybody think that it's not as good as a traffic signal? So you're all very happy with it. Has anybody been disturbed by driver behavior in the roundabout? All right, I'm going to go to you. Why? All right, yeah, we've got, we call those aggressive drivers.
So repeat what you said.
So when they're in the roundabout, there's always people trying to cut you off. I'm going to paraphrase. Cut you off and get in front of you. They're more important than you are, and they need to get places faster than you do. Those are aggressive drivers. Anybody see any problem with the pedestrians or bicyclists? All right, so what do you see with the pedestrian bike? Oh, you saw the pedestrian crash. Anybody else have a problem over here? Philippe? You're not going to say anything. Yes, sir.
The crosswalk that you partially illustrate on your slide is so close to the roundabout that there are people going across that actually might make you stop in the middle of the roundabout.
Yes. So I actually have one small issue with the roundabout, and you found it. I love the roundabout. It is more efficient. It moves more traffic than the traditional traffic signal. With the traffic signal, we tended to have those huge backups all along the Richland Bridge and then up the Richland Hill. We don't tend to have that anymore, which is great. But that pedestrian crosswalk, where it should be placed normally by design standards, is in the direction of where the vehicles exit the roundabout, and the pedestrian is then moved much further down the area. So the only thing they have to look at is that one vehicle, and the only thing that vehicle has to look at is the fact that there's a pedestrian just off to the side of them. Here, right, you're driving and you're trying to figure out, can you use that slip lane to turn right while you're watching cars coming at you? It's too many. we don't want drivers to do more than one thing. More than one thing is very dangerous. So we want them to do one thing, and that is a minor problem with the roundabout. But there's the tunnel. Why aren't they using the tunnel? They don't need to worry about traffic. But let me see if you can figure out what's wrong in these couple of videos. All right, so it's the third vehicle that yelled at him. So here we had that person, right? They said just trying to cut you off. They're more important than you are. They're trying to fit into that gap. But we also had this bicyclist. Now I'm going to replay this. Let's look at where this bicyclist is actually looking. This is what is very strange. What is he doing looking this way? And the reason that we have the pedestrian crossings where they do is so you only have to look at one direction of traffic. So not only are the drivers a little wacky, right? The pedestrians don't know exactly what they're supposed to be looking at. You look at where the cars are coming from, not where they're going to. The rear end of the vehicle is generally not going to hurt you. To look both ways? Yeah. But, well, the fact that he was looking, and it's OU's campus, the fact that he looked at all was amazing, right?
I chose the Cleveland Foundation because they're the experts at what they do. They make you feel very comfortable about giving, and they make it a very fun and rewarding experience. The Cleveland Foundation helps see the possible in Cleveland by envisioning what success looks like.
We have a random person talking. Hold on.
This year, doctors will prescribe sleeping aids to some 60 million Americans.
We don't know why she decided to start talking then. This is my favorite video of all time, I think. Watch, we're going to start in this area right here. I like the crosswalk that he just made. Does he look? Does he look? Oh, there he goes. Now he looks. He's halfway into the lane, and now he looks. And this car has to stop. Okay, that's brilliant one. Brilliant number two person is coming up just in a few moments. I'll give you a hint. It's a white Buick sedan. Oh, no, wait, it gets better. It does get better. He goes down Richland Avenue the wrong way. And so as you start to see him going down Richland Avenue, you're going to start to see a little bit difficult, but there's going to be cars that are going to stack up here because he's on the wrong side of the roadway. There they are. They're stopped now. They still stop traffic. All right, now traffic just started to move. Okay. We're going to cover a few real basic design concepts, right, that we try to do as traffic engineers to not have this happen. Those of you that have driven the roundabout, do you think it would be comfortable to make a left-hand turn there? The guy actually had his blinker on. We generally like to call these things pork chops because it kind of does look like a pork chop, right? And your travel lane and then your curb and gutter. Sorry, you guys can't. You get the idea. So what this is doing, this is putting the vehicle in the position to go in one direction. So we try to design these things to kind of help you out, to give you the idea of it's really uncomfortable. If it's uncomfortable, thou shalt not do it, except in some situations. So that is one of our design techniques that we kind of try to help you out as drivers that maybe don't know the fine necessities and equations associated with traffic engineering. We really try to make the design so obvious that it helps you. I had a couple nice videos of the driving simulator, but they have to be filmed in dark areas so they don't show up very well. But I'm going to give you a little quick glimpse of what happened. So we had a driver without a cell phone, without the cell phone. So no texting, no calling, no receiving, all that jazz. Drove on a snowy road. You're from the Cleveland area, Anthony? No? No.
Yeah, I mean, I've got family there.
Okay. Does it snow in Cleveland? Does it snow frequently in Cleveland? Yeah, okay. I'm from Michigan, and it generally starts snowing in September, and it doesn't stop until June. So we're having this individual drive on a snowy roadway at night in just a regular old snowstorm. Without the cell phone, how do you think he did? Fabulous. No issues. We had him text. He killed himself. He was on a curvy roadway. The road was, it's a snowstorm. The road was icy. It's okay, it's just a simulator. They don't really die. This is why we use a simulator. We can kill people and they still walk away. It's wonderful. So he actually, there was a concrete barricade in the middle. He swerved back, and hit that concrete barricade head on, and actually, in the simulator, broke through the concrete barricade and went into the opposing traffic. Okay, well, in real life, you're not going to break through the concrete barricade. That's just not going to happen. Your vehicle is just going to be maybe from 20 feet to 5 feet. Hopefully you're in the right 5-foot portion of that vehicle. So that was a quick text. So then we had him make a phone call, or he received a phone call from a friend. And he tells a friend, yeah, I'm on your way to your house. I should be there in a few minutes. And as he says that, now he's much further down the roadway with the phone call than he was when he was texting. So that was good news. He actually made it much further. But then he started to continue his conversation, came to an icy spot, didn't go into the concrete barricade, but did drive through another vehicle. So he's probably not dead, but he's probably severely injured. And then the third scenario, we had a friend in the car with him. So those of you that are younger, that are to-be drivers, the worst thing that you can do when you're 16 to 24 is have a friend in the car with you. It is very difficult for young drivers. They are our second worst crashers in the world, second only to adults 65 and older. They have difficulties making decisions because they do not identify a hazard. That's really bright. They don't identify the hazard, they don't know how to mitigate that hazard, so they don't know what to do. They start to do some random behaviors. So a good instance, there's a pavement drop-off edge. We really like it to be about 1/2 inch. So when you go off the roadway for some reason, your one tire hits off, and you try to get back. Well, if you try to get back at a certain angle, you can flip that vehicle. So a good story is a friend of mine had a 17-year-old daughter. She was traveling with her 13-year-old brother. They went out to a movie. They were on the way back home from the movie. They saw a deer. She didn't know what to do. She swerved off of the roadway, and when she tried to swerve back onto the roadway, the tire caught that pavement edge and flipped several times into a ditch. Very happily, they both walked away. However, those are the decisions that hopefully we as adults know you should not veer for a deer. That's the saying. Who wants to be my guinea pig? All right, what do you do when there's a deer in the roadway? Do what? Smack it. I like you. That's exactly what you should do. How much does a deer weigh? A couple 100 pounds, right? How much does your car weigh? 1,500 or 2,000, or depending upon if you've got a large SUV, it could be almost 3,000. Couple 100 pounds versus 3,000 pounds. Who do you think is going to win? Your vehicle is going to win. So don't swerve. Don't slam on your brakes. Slam on your brakes on an icy roadway. Ditch, tree. Hello, EMS. How can I help you? Hit that deer head on, and you will more than likely walk away. Will your vehicle be damaged? Yeah. You're the mother of these two wonderful children, I assume. Would you be upset if your lovely daughter, this is very nice because it's about the same age range. So your daughter and your son go out to a movie and they're on their way back home and they get into a car crash and she says, "Mom, the car's wrecked, a deer ran into me." What's the first thing you're going to say? Are you both okay? And if they say yes, are you going to yell and scream about me through my car? Probably. Where are you? I'll come get you. So that's one of the things that the 16 to 24-year-olds just don't quite grasp yet. As they get older, I have insurance. The insurance will pay for a deer crash. It'll be fine. As long as I can walk away, I'll be happy. As long as any of my friends can walk away, I'll be happy. As long as my child, who's 2-year-old, one day he'll walk away, I'll be happy. So we put the friend in the vehicle, going back to the first story, right? So we have the driver. He's got a friend in the vehicle. Now these guys are actually college students, so that they no longer actually fit in the 20 to 24 range. 16 to 24 range, they're a little bit older. But I told them to pretend that they're sophomores in college. So they were driving along and saying, "Hey, we're going to go to this great party. I wonder who's going to be there." They approach an accident on the side of the roadway. "Oh, man, watch out!" Swerve to avoid the accident on the side of the roadway. They keep driving. Someone behind them is tailgating them. "Oh, no! Watch out, don't slam on your brakes, he's going to hit you." The aggressive driver flips around them, cuts off other traffic. Police officer comes up, he's chasing them. So the aggressive driver and the police officer are now gone. Everything is nice, settled, right? Oh, so they're having a really nice conversation about what they're going to do at this party. Are they going to meet any cute girls? And all of a sudden, there is a bicyclist on the side of the roadway. It's a 2-lane roadway, and there are 2 cars coming at them. What do? So that's death for certain for that poor bicyclist. Well, it's actually better if you, believe it or not, the car that is being passed, do they have a clue of what the heck's going on? They probably do. Have you ever been passed and you see this car coming at you, and then you see the jackal behind you trying to pass you, right? You're like, oh my God, there's not enough room. So you're probably really trying to slow down to avoid the situation. It's almost better to cut across and get into the other shoulder, because this other guy coming at you, who knows what he's going to do. But that was I'll admit it, it was a simulator, and we can design whatever we want in a simulator, so I really kind of messed with the guys. Yes, ma'am. Do I care about what? A car hitting a deer?
You don't care about a car. You care about a car hitting a bicyclist. You don't care about a car hitting a deer.
Oh. Did you like the movie Bambi? So she said, I don't care about a car hitting a deer, but I do care about the car hitting the bicyclist. We have an overpopulation of deer in Athens County. There are plenty to go around. But who would you take? They both got to go. Get rid of both of them. All right. Well, I've got one more question about the roundabout. This red brick surface here, anybody have an idea what that's for? There's always one in the group. So you can slow down? No. You should borrow his answer. Very good. Congratulations. It is for semis or the large tractor trailers or even fire trucks that are having difficulty making that maneuver for them to be able to get around that circle. But we as vehicles should not drive there because it's not meant to be a permanent driving surface. It's just not, the pavement's not stabilized enough for that type of traffic. So please, I know you're going to be the problem right there. You're going to go out there and going to try to drive in that brick, aren't you? So it's for semis. It's to give them that room so they don't have to go up and down in that curb and gutter. Because there are 2 circulating lanes in most of that roundabout. So imagine yourself driving in that roundabout and you're next to the semi, and if they had to jump up on the curb, how would you feel as the car right next to them? Very uncomfortable when you've got a semi that's all of a sudden leaning towards you. So that's why we give them that little bit of extra space to walk upon or drive upon, not walk upon like that other kid. All right, one other cute little / disturbing. This video just wants to play.
Concern.
That's the sleep driving, the eating and
This year, doctors will prescribe sleeping aids to some 60 million Americans, and you may be one of them.
But increasingly, the drug that is supposed to lull you to sleep is showing up in the systems of drivers who have gotten behind the wheel with disastrous consequences. And often, the drivers have no memory of what they've done. Tonight, Channel 3 senior health correspondent Monica Robbins shows us firsthand the dangerous mix of medicine and machinery.
Ambien and its generic form Zolpidem are among the most commonly prescribed sleeping aids. The drug can stay in your system up to 12 hours. Most side effects are minor, but a less common side effect known as complex sleep-related behaviors are cause for concern.
that's the sleep driving, the eating and sleep without awareness, the sleepwalking.
I remember getting on the highway and then I have no memory.
Carrie Kennedy took Ambien and sideswiped a truck. It was also in the system of her cousin, former Congressman Patrick Kennedy, when he crashed into a concrete barrier in '06. In Texas, a woman mixed Ambien and alcohol and doesn't remember running over 2 young girls and their mother. Last May, a man in southern Illinois took 4. And then he drove into a highway construction crew, killing one and injuring 3 others.
It's actually just as bad as drinking and driving.
Researchers at Ohio University use a driving simulator to study and help improve road safety. Dr. Deb McAvoy and her team created a program to test the driving skills of someone under the influence of Ambien. That someone was me. First, I went through a few trials to get used to the Ford Focus. Cameras track my eye movement, and the computer records my speed and how well I stay in my lane.
That's the end of the first one.
I easily passed the field sobriety test. Now I'm ready to take my pill.
The time is 11:28 in the morning, and I'm taking approximately 5 milligrams.
The drug's directions are clear. Go to bed for at least 7 to 8 hours. Do not drive until fully awake. Ambien is designed to act quickly, and it does.
5 minutes, and I'm starting to feel dizzy. I'm gonna lay down for about 10 minutes, and we'll see what happens.
At 11:45, I'm up, but definitely unsteady.
I'm dizzy.
Once in the car, I think I'm driving pretty well, but not as well as before.
Oops, sorry.
We repeat the same process 1 hour after taking the Ambien. I'm clearly disoriented.
Do it again.
Back in the car, I don't realize I'm speeding until the simulator tells me, not once,
slow down,
but twice.
slow down.
2.5 hours in, the Ambien is now at its peak in my system.
I should probably do that again.
Can you imagine actually having to drive a car right now?
No. I mean, I was glad the wall was there.
I'm yawning and fighting sleep. Impatient, I swerve around one stopped car, narrowly missing it. The first part of my final test is over.
I don't think I hit anything. I definitely was fighting to keep my eyes open. I was doing 80 and a 30.
The two biggest things I noticed were speed variance and the ability for her to stay in her lane. As the day progressed, we saw those skills started to deteriorate.
Drowsy drivers have trouble perceiving how quickly they're coming up on another vehicle. And this is a leading cause of crashes. Sobering news for me, but I wasn't done. 3 hours after taking an Ambien, a winter driving scenario. Listen to what Nick tells me right before I start.
The speed limit here is 55.
I begin driving, but within 30 seconds,
Are you all right?
I've lost control and slammed at high speed into a concrete barrier.
Is my car really damaged that I can't take off?
Yeah, you're done.
I'm done?
Remember, Nick told me the speed limit before I started. 1 minute later, I have no memory of our conversation.
I don't remember seeing a speed limit.
This is a very serious crash. You went into the concrete barrier.
Oh, so
You
like...
are not probably walking away from this crash.
So EMS is on the way?
They're on the way.
That's bad. That's sobering, isn't it?
Monica Robbins, Channel 3 News.
Wow, very dramatic demonstration. Now, studies are being done to better understand how the brain functions when under the influence of prescription sleeping medication. And if you do... Okay, so who in here takes Ambien or any other type of sleep aid? So, taking Ambien actually is very similar to drinking and driving. Or taking any other depressant or stimulant while driving. So, the question always comes up, we have all these drivers that are on the roadway today that seem to be doing fairly well, right? We may or may not know that they're having a problem. And crashes are pretty rare. They don't happen all that frequently. And they're not expected. So, the problem that you run into is you have someone that is probably behaving quite appropriately, and yet you've got the other person that's not behaving appropriately. There must be two vehicles on the roadway, or a vehicle and another pedestrian, or a vehicle and a bicyclist, for that crash to occur. So most of the time, if you've been drinking and driving, or texting and driving, or having friends in the car while you're driving, or taking Ambien, or what have you, you should probably thank your lucky stars because you were lucky. And unless you're really, who's good at Vegas? Who's good at gambling? Of course, it would be Anthony. So you might want to give it a try. You can lose big or win big, right? Are you willing to take the risk of losing big? Good answer. So you want to see some other tools that we do for traffic engineering. We had the roundabout, right? And the roundabout was there because we deleted the signal. So we took down the traffic signal. So some of the other nice fun tools that we try to work with they look like little ants on a screen, but what we're trying to do is we're trying to figure out what's the most optimal scenario for traffic signals for a corridor or for an entire city network. So this is replicating the actual traffic volumes, and it's replicating the actual green and the red times, and that kind of gives us an idea of functionality of the system. Now you see it right before the left turn arrows came on. We had a point where everything was red for about a second, right? That is our factor of safety. So your factor of safety when you're on the roadway, most traffic engineers use, is about 1 to 1.5 seconds. Anybody been at a left turn signal and it is a span wire signal? It's a brand new eraser, it should work well. Okay, so it doesn't work well. All right, so you're at a signal, there's your span wire, there's your left turn signal, and in order to be able to turn, you have to park right about there to make that turn. Anybody been in that situation? You want to turn left, but you cannot see that left turn signal? I'm sure we've all been there, right? Well, what that all red interval does, that 1 to 1.5 seconds, that gives us time to let you get out of the intersection before we have oncoming traffic. So that is exactly what that is used for. Now we also have those very aggressive drivers, right? There's a huge difference. Anyone here from the East Coast? I'm going to have to pick on you. Have you ever heard, okay, what do you do at a left turn signal, Rox? Do you wait patiently?
No, you pull up into traffic and you pray that you have enough time to make the left before you get smacked.
Okay. Fabulous. So in the East Coast area, we have what we call left turn jumpers. They actually begin to turn left before the signal is green. Yeah. The Midwest, we're a little bit more passive aggressive. We're called left turn sneakers. We inch up into the intersection on our protected green, waiting for traffic to clear, and then the light turns red and then we turn, right? That's tends to be what the Midwestern folks do. Both of them are, one's passive aggressive and one is active aggressive. It doesn't matter. They're both aggressive. They're both hanging out in the middle of the intersection when they should not be. So we actually have to design for our aggressive drivers as well as try to design for any of our drivers that are impaired. We'll try to do the right thing for you. We'll try to give you as much pavement markings and as much sight distance as possible. But you need to help us work with that as well. All right, the last thing I want to do, who's got a smartphone? Dr. McMills has it. He's sitting right here. Okay, you've got a smartphone, and you have your lovely wife next to you. So she's going to help us out. If you could put it on stopwatch, okay? Do you know this gentleman sitting next to you? No? Philippe, do you have your smartphone with you? Yeah. Do you have a stopwatch capability? When I do something, you're going to hit him, okay? You don't know him, but you will know him soon. You've probably smacked him upside the head a couple times, so you should be okay. How about you two over here? Do you guys know each other? Okay, you will know. Who's got the smartphone? You got the smartphone. Stopwatch capability. You get to hit him. That's why you said you didn't have a smartphone, wasn't it? No. Okay. She wants to do it. You're going to hit her. Okay. Close your ears.
Close my ears?
Yes. Your ears. When I blink at you, hit him. Okay. Okay, you're good now. When I blink at you, hit her. I'm walking all over the place. It's driving them nuts. When I blink at you, hit. When I blink at you, you're going to hit him. Okay? All right, so when you are hit by your new friends or old friends, I want those of you that have the stopwatch to go ahead and, as soon as you feel the hit it, and then quick hit it again. Okay? So do 2 quick taps. Okay, what number do you have?
2.72.
What number do you have? Oh, you cheated. Rocks? 0.46? Oh. That's too bad, isn't it? Ah. All right, so this was not the best, but what we were doing, we were kind of testing your reaction time, right? So everything that we do, we have this lovely equation. I know you guys hate equations, but all right, we have this equation. 1.47 times the speed of the roadway times t plus the speed of the roadway squared divided by 30 friction factor plus or minus the grade of the roadway. Okay? T is your reaction time. So when we talk about reaction time, that T is actually, we just tested your quick reaction, right? We did not test. So in addition to these numbers, we need to add the ability of you to perceive that there's something going on, the ability of you to figure out what the heck that is in the roadway. You have to make a decision, and you have to act on that decision. So we call that our PIEV time. But that's generally what it is, and that all goes right into that T. There's always excuses. So you're probably right about 64 years of age. Mark, you're going to love this. You and Rox are going to absolutely love this. You're approximately 16. You thought you were going to retire. Nope, you got to start all over again. So what we start to see is we use a general reaction time, general perception plus reaction time of 2.5 seconds. So that's that perception, make a decision, see something, decide what to do, make the decision, and act upon it. we expect that's on average 2.5 seconds. For those of you that remember the card catalogs in the library, I like to think of it that you have a card catalog in your head of driving maneuvers. When you are approximately 30 to 54, those are our perfect drivers on the roadway. Of course I am. The younger drivers have a really great perception reaction time. It's generally much lower than 2.5 seconds. Older adults, 65 and older, have a much higher perception reaction time, much longer than 2.5 seconds. Well, what happens with the younger folks, they have a great perception reaction time. They have crappy delivery, right? They've got this card catalog, and they're like, oncoming car and a 2-lane roadway. Okay, I'll do this. Older drivers. Oncoming car and a 2-lane roadway. I know exactly what I should do. Oh, do it. So the younger drivers can retrieve the information very quickly, but they have no clue what to retrieve. The older drivers know exactly what to retrieve, but the reaction time, just because of the aging process, tends to slow. And the 30 to 54-year-olds, there is gradual degradation as we go through our ages, but we really start to see it hitting, what's the difference of 2.46 and 2.5? Not a lot. But when we start to have 3.5 seconds, we really start to see an impact on our ability to stop or make a decision because of that one massive equation that we use. So we've got a lot of drivers on the roadway. We've got a lot of drivers that don't know what they're doing on the roadway. Unfortunately, I think driver training needs to be a little bit more advanced to help us have our youngsters know how to identify the hazard, how to react to the hazard in appropriate fashion very quickly, do some more training with our older drivers to get their reaction times up to snuff. With constant use, they'll be able to get there. But we're still trying to design the roadways, given all these constraints, to benefit everybody in all of those categories. So bear with us if we make some mistakes, like the pedestrian crossing at the roundabout. But in general, that's what we're trying to do as traffic or transportation engineers. All right, so with that, I'm just going to open it up to all sorts of questions. Hopefully you're just dying. Okay, fabulous. Oh. Yes. Yes. Okay. So, when you're in Washington, D.C., you can travel. I got other issues with Washington, D.C. we'll get to in a second, too. You can travel through all of the traffic signals, and as you approach the signal, the light will turn green. And that is generally what we do with the SynchroSim traffic program. That's how we improve the progression. This is a before. Nothing really worked here well. So when you have a traffic engineer on staff or multiple traffic engineers on staff in these very large cities, you generally have a group of 5 to 6 traffic engineers that sit around all day, and this is all they do. There's cameras at a bunch of the intersections. They're monitoring exactly what the flow of the traffic is at that very moment, and they can go in and change the signal controllers remotely without even having to go in the field. They know exactly what's going on because of the detectors and the cameras. When I was a traffic engineer in Michigan, that is what I did, and I thought it was so cool. Especially the day that I got a call from my boss, who was the manager of the city, and said, there's a traffic jam and I need to get home. Yeah. All right, now in Washington, D.C., they have reversible lanes, yes? Yes. Who hasn't been to Washington, D.C.? Okay, come here. If you would stand here and face Roxanne, please. So you're driving down the roadway. You're driving towards Roxanne. You don't have to move. You just have to stand here. All right. You're driving down the roadway. You're focused this way, right? Do you see this thing over here? Don't look at it. What color is this? Oh, you're lucky because you cheated. All right, so in Washington, D.C., thank you very much. In Washington, D.C., they have these signs that are in your peripheral vision that tell you what lanes you can and cannot travel in during certain times of the day. And the text, ma'am in the lovely roses shirt, can you read this? Really? You have difficulty with that? That's funny. Yeah, so that's the size, generally the size of the text in general that they have on the side of the roadway telling you that you can or cannot drive in the lane in which you're traveling. Sorry, is that better? So when you're traveling down the roadway and you happen to be within that half an hour time period when things are going to change, and you're traveling in the lane and all this traffic is coming directly at you in the same lane, the one thing you say is, what time is it? And am I supposed to be, which lane am I supposed to be in? And you can never find that sign when you need it. That's my issue with Washington, D.C. They need some overhead signage for visitors. Okay. So the second part of your question was, do we have the ability in Athens, Ohio, to make sure that you get through all the signals appropriately? Mark, would you like to answer that? He's sitting over here giggling. So the problem that we have is there are very few traffic engineers that have been trained appropriately. We have this wonderful program, and Brandon knows this. I'm gonna pick on you now. This program, any monkey can use. It has a wonderful optimize button. You want to optimize all the signals in the network, you just hit the button, and Brandon, what happens? It messes it up. But that is what all the traffic engineers generally that predate, graduated before 2007, that's generally what they know. Now, Brandon knows better. He took my class. He better know better. He knows that if a monkey could do it, then why don't we just hire the monkey? So the reason we have traffic engineers in large cities like Washington, D.C. or Chicago or San Francisco is because it does take more than a monkey. So there is things that you need to go in here and finesse to actually get that to happen. So large cities have it because they can afford to have those 5 to 10 traffic engineers focused on the roadway system 24 hours a day. That's all they do. City of Athens, we have an electrician that uses and updates the traffic signals. Not one day of engineering education or traffic engineering experience. So he's probably not, and that's probably not unlike 98% of America. All right.
At most every left turn signal, the pavement sensor.
Yes.
At least one car length back from the stop line. And I'm wondering, is that because traffic engineers think that's such a great idea, or is there some regulation or standard that forces them to do that?
Okay, well, okay.
You might have a feeling for what I think of it.
So, absolutely not. So the question is, this gentleman seems to think that all the left turn sensors or the detectors that are in the roadway are set back one length of a car. Well, they should not be. I actually like to place it about a foot, starting a foot in front of the stop bar and then going back about 40 feet and 6 feet wide. I can't control everything. Go to Michigan, you'll see it a lot. Yeah, okay, yes, we don't see it around here, unfortunately. So yeah, setting that back a whole full car length behind the stop bar, there's a couple different ways we can operate signals. If that left turn is guaranteed sometime, it'll probably be guaranteed enough time for that one car to turn left. So maybe what they're thinking is if it's pushed back for that second car, they're going to increase, which is called the gap extension, increase the green time to get more than one car beyond. But then that detector should also extend much further back in the roadway to figure out how many left turn vehicles are there so they can keep extending that gap or that green time to be able to fit all of those vehicles through that left turn signal. You're not going to, so then it is a fully semi-actuated signal. Yes. Again, we go back to the education issue. There are a lot of traffic engineering professors across this country that are trying to work on getting the knowledge out. A lot of these new fandangled tools and equipment such as detectors, camera detectors, all the accelerometers. This is new technology. Cities have to be able to have the money to afford that and have the individual that has the technical expertise to know where to put that. So there's a lot of issues happening, particularly more in rural America, that it's very difficult to kind of fix everything. I did a lot of work in Michigan for rural communities, and it has been an Institute of Transportation Engineer standard that's through the Federal Highway Administration. All signals will have a 1.5 second all red interval, just like we talked about, so you could turn left without getting hit by traffic. 100% of the signals that we were looking at did not have an all red interval. And this all red interval, this is really basic stuff. You don't need any new fandangled equipment or technology to do this. This all red interval actually came into being, well, I want to say like 20 or 30 years ago. And in 2007, 100% of the intersections, and we looked at over 560 intersections, 100% of them did not have the all red interval. And we said, did you not get the memo from the Federal Highway Administration? Did we? If you had a signal, you got the memo. It came from the DOT to you, to all municipalities. So, again, give us some time to get, of course, Brandon left, Anthony and Philippe out the door. They're going to know what to do, so the next generation, I think we're in great hands. But we're in a period of transition right now, which is unfortunate. All right. Yes. Okay, so there's a couple of different detectors that we can use. We have the traditional wire detectors, and those are detecting vehicles based upon the electromagnetic field. So the problem that we do have, not with bicyclists simply do not have enough metal on them to be able to be detected by one of those types of detectors. But motorcycles, where those two arcs form, they actually cancel out the detection. So motorcyclists, if they're parked directly smack dab in the middle of the lane, will not be detected unless you can turn down or increase the frequency of that electrical circuitry. We also have, in those cases where there's several bicyclists, we probably wouldn't use those metal wire detectors. We would use camera detectors. And the problem with those camera detectors, it's to grayscale, and it's trying to detect shadows or different coloration from the pavement of the vehicle that is sitting there. And if it senses that there's a color differentiation with the pavement, it will talk to the controller, and the controller will change the signal. Well, if you have one bicyclist that is there, that camera may or may not notice that bicyclist sitting there. Even if you had a couple of them, you really need that large shadow in order to get that signal become actuated. Now, there is new technology to help out with the detection of bicyclists. Vancouver's done a fairly good job with that technology, and it's starting to filter through other major cities. So maybe by the time you go back to California, they'll have it.
What kind of technology is supposed to
It's a combination weight and electromagnetic. So it can also sense a weight change within the pavement or a differential. So therefore, any normal person is about maybe 150 to 200 pounds. That should be enough to be able to be detected by a weight detector. But that was the last question. Sorry, Anthony.
Thank you very much.
You're quite welcome.
And she'll be up here if you guys have any questions or want to talk to her about anything. I'm sure she would be happy to talk to you guys some more about her work. Don't forget, the next Science Cafe is 3 weeks away on December 11th. See you guys then.